Hi, welcome to this session. This is Online Math Academy. This is a special session for my Year 7 Computer Science students. So I did a session for math, my Year 7 math student, a YouTube session. Now, to be fair, I have to do for my computer science students before I get complaints. All right, so in this session we are going to talk about binary numbers. So what are binary numbers? Well, they are numbers that computers understand, the only thing that computers understand. So before I get into too much detail of binary numbers, let's talk about our own numbers that we know. So we count from 0 all the way to 9, and then we start all over again. So we start, when we get to 9, we start with 1 and a 0 again, all the way to 19, and then we get to 20, and we repeat that process. So you know from primary school, what did you have? You had units, you had tens, you had 100, you had thousands, and so on. Okay, as you went to the left, the numbers got bigger. So for example, if we had a number 2,300 and let's say 72, how do we represent that on this number line? Well, how many units do we have? We have 2. How many tens do we have? We have 7 of them. And how many hundreds do we have? We have 3. And how many thousands do we have? 2. So really, this is like having 2,000 here, and we have 300 here, we have 70 here, and we have 2 units here. So what it is, we count in base 10. Our numbers are called base 10 numbers because we count in tens. So computer only understands 1 and 0. So they are called binary numbers. What are they? Well, it's a number system that only uses 2 digits. Only 1 and zeros. That's the only thing. Everything in a computer has to be in 1 and zeros. Ones or 0, 1 and zeros, but nothing else. So colors, we see yellow, blue, green. Computer sees 1 and zeros. Or sound, we hear high pitch, low pitch. What does the computer understand? It sees 1s and 0. Our lovely text, we write in all sorts, letters or colorful letters. What does the computer see? 1 and 0. What other languages? What does computer see? 1 and 0. Right, so how do we compare the two types of number, decimal numbers and binary numbers? Now, if you remember now again, from primary, you had units, you have tens, you had hundreds, you had thousands, and 10,000, and so on. You get the point. Now, for units, you had 1, and then you had tens here, you had hundreds, and then you had thousands. These are the numbers that you use. Every time the number got to 100, it gets moved up here. There's no more tens. So for example, if you had number 11, you will put 1 here, and remainder, the units is 1. So then you get 1, 1. Now, how do we do this in binary? Well, for binary, we still have 1, but because we are only counting in 2s, we only have 2 digits, 0 and 1s. So the next one is going to be 2. The next one, instead of hundreds, we're going to hit 4s. Instead of thousands, we're going to have 8. And then instead of 10,000, we're going to have 16. You get the point. It's doubling as you go to the left. So just in case you wonder where these numbers came from, that's because when we write in binary numbers, we write in base 2. So We call them base 2 because they are only 2 digits. So the first number is 2 to the power 0. Second number that we get is 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4. So this is how you get these numbers, okay? Now remember, 2 to the power 0 is 1. Whereas for decimals, what did we have? We had them in powers of tens. So we had like 10 to the power 0, and that gives you 1. 10 to the power 1, and that just gave you 10. 10 to the power of 2, and that gave you 100. 10 to the power of 3, and that gave you thousands. So instead of 1, 10, 100, 1,000, for binary, we have 1, 2, 4, 8, 16. That is the method we're going to use. So every time you convert numbers from decimal to binary numbers, I want you to use these lines. Before you do anything, you write your reference line. So we got 1, 2, 4, 8, 16, 32, 64, and so on. So we go from right to left. So you can see the numbers are getting bigger towards the left. Right, so let's just start with some really small numbers here. 5, 3, and 7. And we're going to convert these numbers into binary numbers, okay? So the first thing you want to do is write your reference line. 1, 2, 4, and I'm going all the way just up to 8 because my number doesn't really get to 8. Right, let's draw this table. All right, now you're going to ask yourself, how many 8s can you get from 5? Well, the answer is none, so that's 0. How many 4s can you get from 5? Well, there is only 1, and you are left with 1. If you use 4, you're left with 1. So how many 2s can you get from what you're left? You're left with 1. None. So we're going to write 0. And then you still got 1. How many 1s can you get from 1? So it's 1. So 5 into binary number is 0, 1, 0, 1. Let's do 3. How many 8s can you get from 3? 0. How many 4 can you get from 3? 0. How many 2 can you get from 3? Is 1, and you're left with 1 from here, and in that way you can get another 1. Now let's talk about 7. Right, 7, we got how many 8s can you get into 7? Well, none, 0. How many 4s can you get from 7? Only 1. So you're left with 3, and now you're going to ask yourself, how many 2s can you get from 3? Only 1, and now you've used 2, you are left with 1. How many 1s can you get from 1? Well, 1. Okay, so let's try one more number, okay? So let's put a bigger number here, 9. How many 8s can you get from 9? Well, you can get 1 8, and then you are left with 1. How many 4s can you get from 1? 0. How many 2s can you get from 1? 0. How many 1s can you get from 1? Is 1. So 9 in decimals in binary is 1, 0, 0, 1. All right, so just to let you know, binary numbers are called base 2 numbers because you only count in 2s. 0, 1, 0, 1. There are only 2 digits, so they are called base 2 numbers. Let's see some funky examples here. Right, so if we have 3 pounds in base 10, okay, 3 pounds in base 10, which one is going to be more? Is it going to be more in binary or more in base 10? Let's have a look. So we're going to put our numbers here. What do we have? We start with 1, and then 2, and then 4. Well, we don't need to go that far because we only got 3. So you're going to ask yourself, how many can you fit here? How many 4s can you fit into 3? None. So that's 0. And how many 2s can you fit in 3? 1, you're left with 1, and you can get 1, 1. So 3 pounds in base 10 is 1, 1 in binary number. That's what computer says. So if that was money, then that would be worth more if you ask me. 4 pence in decimal. How many pence will that be in binary? I'm going to pause the video and you guys work it out. All right, let's go over the question. So we're going to start by doing 1, 2, 4, 8. I'm going to stop there. So how many pens, how many 8s can you fit into 4? 0. How many 4 can you fit into 4? Well, 1. How many 2s can you fit into? Well, you've used 1, so now you have only got nothing left. So 0, and there's no number there, so we got 1, 0. So it's 100 pens in binary, guys. Right, now 3 computers in denary or decimals. How many computers are there in binary? Well, how many 4 can you fit into 3? 0. How many 2s can you fit in 3? 1. How many 1 can you fit into 1? Because you used the 2, so now you got 1 left. You can fit 1, 1. Okay, so there are 11 computers in binary. At least that is what the computers see, 1, 1. Okay, right. Now we're going to ask yourself, how many chairs are there in binary? I'm going to give you 30 seconds to work this out. Right then, so we can see 5 chairs in decimals. We're going to convert that in binary. You can see you got 5. So how many 4 can you fit into 5? Well, 1. So that's used, that's used, and that's used, and that's used. We've got 1 chair left. How many 2s can you fit into 1? 0. How many 1 can you fit into 1? Well, there is 1. So 101 chairs. Right, here we go. How many phones are there in binary, guys? Well, how many we got? We got 6 in decimals. We're going to ask ourselves, how many 4s can you fit into 6? Well, 1. So I've used them. I've used those 4. I've got 2 left. How many 2s can you fit into 2? Well, 1. And I've used all of them now. How many 1s can you fit into? There's nothing, so 0 there. So 110. Right, guys, now we have 2 cars. How many is that in binary? You have 30 seconds, guys. Right then, so how many 4s can you fit into 2? 0. How many 2s can you fit into 2? 1. And then now you have used 2. There's nothing left. So how many 1s can you fit? 0. So that's 10 cars. Okay, now we have people. How many people are there in binary? Well, there are how many in decimals? 1, 2, 3, 4, 5, 6, 7 in decimals. Now, let's see how many there are in binary, guys. 30 seconds again. Right then, so how many 4s can you fit into 7? Well, 1, 2, 3, 4. There's 1. So now I've got 3 people left. How many 2s can you fit into 3? Well, I can use that one and that one. There's 1. And then how many 1 can you fit into 1? So that's 1. 111 people there are in binary. All right, guys. So now for the plenary, here we go. Here is a number. So I'm going to give you a number 27. We want to write this in binary. So we're going to start with 1, 2, 4, 8, 16, and 32. Right, so remember they are doubling as you go to the left. How many 32 can you fit in 27? 0. How many 16 can you fit in 27? Well, you can only fit 1. So now we're going to do 27 take away 16. So that's going to be 11. Okay, so Now you're going to ask yourself, how many 8s can you fit into 11? Well, there is 1. And if you use 8, you're going to be left with 3. You're going to ask yourself, how many 4s can you get from 3? 0. And then you still got 3. How many 2 can you get from 3? 1. And now you've got, take away 2, you've got 1 left. So how many 1s can you fit into 1? Well, it's 1. So the answer to that, 27 from decimal to binary is 0, 1, 1, 0, 1, 1. That is what the computer sees. Alright guys, in the next lesson, I'm going to show you how to convert from binary to decimals. Bye for now.